In this video, we'll talk about analyzing data on two categorical variables. To begin, we'll look at an example that we'll use for the majority of this video. So let's say that the Yellowstone National Park staff surveyed a random sample of over 1,500 winter visitors to the park. So they asked each person whether they belonged to an environmental club, and they also asked them about their snowmobile use, whether they owned or rented a snowmobile, or if they'd never used a snowmobile before. So this is what the data will look like for the first 5 respondents. Obviously, we're not going to show all 1,500. So a good way to display all of that data of over 1,500 respondents is in a two-way table. So a two-way table is a table of counts that summarizes data on the relationship between two categorical variables of some group of individuals. So the group of individuals are those 1,500 plus respondents to the survey, and the two categories are their environmental club membership, whether yes or no they are a club member, and their snowmobile use, with never have they've rented or they've owned. Using a two-way table, we can extrapolate a lot of information. So let's try to answer 2 different questions. The first being, what % of people in this sample are environmental club members? So the first thing that I do is I look at the table and I look for, all right, how many people answered yes to, are they part of an environmental club? So that's going to be 305 folks. And then what we do there is we put the total number of respondents in the bottom. And so that's going to be that 1,526. And so that's not a percent, that's just a proportion, that's a ratio. And so when I divide 305 by 1,526, I get about 0.200, and that is 20%. That's a nice number. Another question we can answer is, what proportion of people in the sample never used a snowmobile? So I'm going to look at our never used row, and I'm going to look for the total. So that's 657 folks. And so it's asking what proportion of the total, which is that 1,526 number. And it's not asking for a percentage. Now, this is a proportion, but we can also turn it into a decimal, which is 0.431. The answers to the questions that we just found are what we call marginal relative frequencies. So we talked about relative frequency tables before, and those are tables that have percentages or proportions in the table instead of just the frequency. And so when we introduce the word marginal, a marginal relative frequency gives the percent or proportion of individuals that have a specific value for one categorical variable. So the questions that we just answered were about, what % of people are in the environmental club and what proportion never use a snowmobile. That's one category. And marginal relative frequencies deal with one category that essentially live in the margins. So that's these totals here or over here, and it's only for one thing. Now, what if I wanted to find a combination or things that affect 2 categories? So let's answer some of those questions. For example, what % of people in this sample are environmental club members and own snowmobiles? So I'm going to look for the intersection of the environmental club, so that column, the yes column, and the snowmobile owner column, or row rather. It's going to be here. So that intersection is going to be 16. So when it's asking for what % of the people in the sample, so that's 16 out of the total. And so that's not going to be a big decimal. It's about 0.010, which is about 1%. Pretty small. And so for our next question, we wonder what proportion of people in the sample are not environmental club members and never use snowmobiles. So it's very similar to the other question, except we're going down the no train instead of the yes train. So not environmental club members, that's going to be this column here under no, and then never use snowmobiles. So it's going to be the intersection here. So 445 people have not used a snowmobile and are not in the environmental club. So that's going to be that proportion, which as a decimal is about 0.292. So that's almost 30%. I know they wanted a proportion, not percent. But that's how we bring two things together and find the intersection and their values. So what we just found is something that we would call joint relative frequency. So that gives the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. So that just means two things instead of one thing. So compare that to what we found first, which was marginal relative frequencies. So essentially, if you're looking at a chart, the joint relative frequencies exist in here, right? So that's that not an environmental club, never used a snowmobile group, whereas the marginal relative frequency only had to do with one of those variables, whether they were a snowmobile owner or they were just an environmental club member. So marginal, one thing in the margins, joint, two things in the middle of the chart. So while those frequency tables tell us a lot of information, it doesn't really get to the relationship between all of those individuals and variables, meaning I don't really know the relationship between being a member or not of the environmental club and whether or not I've used, owned, or rented a snowmobile before. So there's something that we can create called a conditional relative frequency. So that gives the percent or proportion, which we've been doing, of individuals who have a specific value for one categorical variable among individuals who share the same value of another categorical variable, which is the condition, hence conditional relative frequency. So let's put that into practice because words are confusing, at least to me. So let's answer the question, what are the percents of environmental club members who never use, who rent, and who own snowmobiles? So to find the percentage of environmental club members who never use a snowmobile, I'm going to go to yes, which is all going to be in the same column, and over to never used. So that's 212, and that's out of our total of 305. And when you divide that out for a percentage, 0.695, which is about 69.5%. Now that's 69.5% of environmental club users that have never used a snowmobile. So let's do the other two. And using that same process, I find that 77 environmental club members have rented a snowmobile. So that gives me about 25% of those club members. And 16 out of 305 have owned a snowmobile, and that's only 5%. And of course, we can do the same thing with those that are not environmental club members and figuring out what the percentage or proportion would be of their snowmobile use, whether they've never used one, they've rented, or they own one. And so this is an example of a conditional relative frequency table where we have this information and we can compare the relationship between these variables. So we have collected and organized that data, and now it's time for one of my favorite things to do with data, and that is to visually represent that data. And we've talked about a bar graph before, and so these are two different types of bar graphs when you have multiple variables. So the first is a side-by-side bar graph, and so that displays our distribution of a categorical variable for each value of another categorical variable. So if you've got two, this is how you represent them. Please notice that we have the environmental club membership down here on the bottom, so that was like the top part of our table. And so we categorize it as no, I'm not a member, and yes, I am a member. And then on the y-axis, we have the percent. So the percentage that either never rent or own a snowmobile. So color coding it is great. What you can do is you can have these three separate bars for no and for yes. Pretty self-explanatory. Now, A segmented bar graph takes all of those things and stacks them on top of each other. And what I mean by that is I take all of my no's for never owning or using, renting, and then owning a snowmobile. And so you'll notice that the percentage of blue stays the same, and then the percentage of red gets stacked right on top of that, and then the percentage of green gets stacked right on top of that. You do the same for no and for yes. So, two different ways to represent a bar graph. And stay tuned. At the end of this video, I will show you, using a different example, how to make a segmented bar graph. Now here's a great thing that visual displays of data, like segmented bar graphs, do for your extrapolation. And that's something that we call association. So, a bar graph, for example, will help you figure out whether two variables are associated or not. So, the definition goes something like this. If there is an association between two variables, that means that if knowing the value of one variable helps you predict the value of another variable, there's an association. And you can figure out that if there's knowing the value of one variable doesn't help you predict knowing the value of the other variable, then there's no association. So not every piece of data or frequency relationship has an association. So, for example, with our snowmobile environmental club use segmented bar graph that we have right here, there's an association. We could say that environmental club members were much less likely to rent or own snowmobiles. In fact, it's much more likely that they will have never used a snowmobile than, say, non-environmental club members. They are more likely to rent or have owned a snowmobile. Now, what would it look like if that information didn't have an association? It would look something like this, where the segments, so the green, the red, the blue, the owning, renting, and never using a snowmobile, doesn't really help us predict anything. So being an environmental club member didn't really have an effect or an association on snowmobile use. And one last thing, association does not automatically imply causation. That doesn't necessarily mean that you're going to find the cause of something. Just because something has an association doesn't automatically mean, oh, that's why, there's the cause. But you knew that. All right, here's where we're going to work through an example of creating a segmented bar graph, if you care. So we're going to use an uplifting example of the Titanic disaster. Ooh. So in 1912, the Titanic sunk. We know this. Some passengers made it off the ship in lifeboats, but many died. So there's this two-way table that gives information about adult passengers who survived and who died by their class of travel. So that's first class, second class, and third class. So let's find the distribution of survival status for each class of travel and make a segmented bar graph from those, and then we'll talk about any kind of association there might be. So here's how I like to think about this. So I'm going to take each class. So for first class, I'm going to figure out the percent that survived and the percent that died. So the percent that survived in first class is going to be 197 out of 319. So that's still my first class. And then the amount that died is 122 out of 319. And so I'm just going to skip right to the percentages. 61.8% survived in first class and 38.2% did not. So I'm going to do the same thing for second and third class, whether they survived and died, and we'll come up with those percentages. So for the second class, we've got 261 total second class, 94 out of 261 survived, and 167 out of that 261 did not. So that's 36 and 64% respectively. Same process for the third class, 24% survived, about almost 76% did not. So if you want to think about that in terms of a new kind of table here, we've got the percentage that survived in each class and the percentage that died in each class. So what we're going to do is we are going to create a segmented bar graph. And remember, that's when you kind of stack those bars on top of each other for each variable or category. So what I've done is I made the x-axis the class of travel, so that's going to be for first class, second class, and third, and then on the y-axis is my percentage. So let's do survived first, because that's more positive. I'm going to make that into a blue bar. Wow, words. So much like a regular bar graph, I'm going to match those percentages with first, second, and third. Survival. So first is going to be up here about 62, 36 for second class, and about 24 for third class. So what I'm going to do next is, using the same width of my bar, but in red, I'm going to stack that 38.2, 64, and 75.9 on top of that. So here we go. Obviously, there are fewer folks that died here in first class than there are in third, but something that you probably already realized even before I put in these red bars is that each of these total segmented bars here, first, second, and third class, should add up to 100% because it represents 100% of first class, 100% of second class, and 100% of third class. So that's how you make a segmented bar graph. So the second part to this problem is to essentially analyze what kind of association there are between class of travel and survival status for the adult passengers of the Titanic. So hopefully you can recognize that there is an association here. So I would say that yes, there is an association because depending on your class of travel, that impacts your survival status. So you are more likely to survive if you are in first class versus second or third class. Woo, give yourself a round of applause. You made it through the video. Thanks for watching.